Assalamu alaikum, doctor. My name is Salma Yasser. Today I'll be presenting about the demonstration of the Turtle Pot. The main project, as mentioned before, is a Turtle Pot 3 implementation in food and beverage industry, especially in the restaurant base. My group members are Nashita and Izzati. So firstly, for this part of the video, I'll be talking about the advantages of Turtle Pot in restaurants. So as we know, there is a strong community of support for TurtlePod, and that has been the main advantage for our project. A number of research labs have adopted this system for the purpose of conducting multi-robot research as well as human-robot interaction research. It is also maintained by the Open Source Robotic Foundation and is interconnected with a wide variety of open source software package, many of which are available for download and use in any mainstream operating system. For the operator and the staff of a particular restaurant that uses our floor plan model, this will be very helpful in any handling and maintaining of usage for them. They may have for the restaurant, because our system has three main points, which are the kitchen, customer, and washing area. So the movement of our system of the floor plan goes from the kitchen, which is the origin point, goes to the customer, okay, and it goes to the customer after the customer have already done his or her order using the application of the restaurant. So usually the restaurant should have an application that's connected to the robot. So when the customer order while he or she is in the restaurant, then the order will be sent as a QR to the robot, and the robot will show an ID number to the kitchen. Then by that, the chef will know what order is that, and he can cook the meal for the customer. Once the meal is finished and it's ready to serve, a LED will be blinking. So the robot knows once the LED blinking, the robot will go to the kitchen to pick up the meal and then goes to the customer. Will serve the meal to the customer, and then the robot doesn't have to stay in the same position until the customer finish his meal. So the robot can go back to the kitchen and serve any other customer. And once the customer finishes eating his or her meal, then there will be an LED on the table blinking. So by that, the robot will know that he has to go and pick up the meal or the dish back from the customer table. After picking up the dishes from the customer table, it will go within the floor plan direction to the washing area. Then it will continue going on that loop as in the floor plan. Thirdly, it can be programmed to run the SLAM simultaneous localization and mapping algorithm to create a map of the room and then move around the room. Thus, in a restaurant food and beverages setting where there may be more than one location involved as the initial and an end point of the operation, this method will make it easier to move the robot around the room. And that's how we solve the problem of the movement of the robot, where it needs to go forward and backward from kitchen to customer, customer to kitchen, and so on. Using the TurtlePod also has an advantage of being able to be monitored and controlled remotely from a laptop, a joypad for smartphones that run the Android operating system, and a joystick for iPad models. This is also another way of solving the problem. The TurtleBot 3 provides the same SLAM and navigation capabilities as the TurtleBot 3 to compensate for the lack of freedom. By reassembling the mechanical parts and using optional parts such as computers and sensors, TurtlePod can be customized in a variety of ways depending on the requirement of the restaurant. Then secondly, we'll talk about the experimental error faced during our demonstration. Firstly, TurtlePod was moving at a design movement of the floor plan until the starting point location was altered halfway. This can be linked to the fact that in an initial setup, there was a test run done before the actual demonstration. To clear this point is that before we do our demonstration, another group was done with uploading his code into the TurtlePod already, which his code requires an angular velocity or angular movement of the robot. So in that case, when we tried our coding during the demonstration, we directly upload the code after that group. So we didn't refresh or restart the robot. That's why when we have done our floor plan movement in during the demonstration, follows the exact movement given in the floor plan, but the error was that it goes in an angular velocity or with an angular motion, not in a linear motion. And that was because of the previous code uploaded in the TurtlePod. And secondly, talks about the recent exposure to the hardware and software used. We didn't project the fact that there was a presence of an angular velocity, as I've mentioned already, and that movement have caused our robot motion, but there wasn't any error for the robot to follow the floor plan designed during the simulation. Also, one error is the weight of the battery. That actually, it's a supplying power to the bot, but it's very heavy or thick to be placed on top of the robot, and that might also cause the slow movement of the robot than usual. The solution and the future work for our project is that we've planned to maximize the efficiency of the robot by thoroughly taking into account all the possible variables that may disrupt its simulated movement into actual implementation. Problems such as initial setup must be freshly connected so that the TurtlePod understands the message being signaled and conveyed to it, thus successfully executing it. Where angular displacement is concerned, the operators of the system should be aware of the possible changes on the actual demonstration. Thus, the coding and the system configuration must be thoroughly inspected beforehand. Beside that, the proper dimensions with the appropriate amount of voltage for the battery power is of importance as well. Then here is the video to show our demonstration. So I've seen the TurtlePod. In order to start the floor plan, it will go different rotation, like it will rotate on the same position for around 2 or 3 rotations, then it will start to follow the floor plan. Right now, it's following our floor plan, and it's going from the kitchen part to the customer, and then customer to the washing area. So at this point, it already reaches the customer, and then goes from customer, and then walking within our floor plan to the washing area over there. And then from washing area, it will come back again to the kitchen. So at this point here, it's going to the washing area, and then it will go to the kitchen. And sorry for this interrupt, we couldn't record the whole video of the demonstration because of lack of time during the presentation. So as we have tested before, it actually continue the process of the floor plan and move from the washing area back again to the kitchen. Okay, thank you for listening, and hope you enjoy our video.